all the previous ones that we did. Okay. It's got nothing to do with what we already did, and that's known as KPC, or it's also known as, I mean, it's not, I mean, this is what it is, partition coefficient. Okay, so it's an equilibrium constant, product concentration divided by reactant concentration. Like it's got nothing to do with what we just did. pH, Kw, Ka, Ksp, nothing whatsoever to do with that. So first thing, they're going to ask you what the partition coefficient is, though. So it's the ratio of the solubility. I mean, that's the words that you're going to use. Solubility of a solute in in two different immiscible solvents. Immiscible means not mixing with each other. So this is the technical definition that you're going to write. I said, but what is KSP? So you've got a lot of immiscible liquids. One example is oil and water. So you have water over here, and let's say you have oil over here. Okay, oil ki bajaye I'm going to write hexane. So this thing over here is known as partition. The boundary is known as partition. So oil and water or hexane and water will have two layers. Or इनका volume भी लिखते हैं. Let's say this is 50 cm cube and that one is, you got 30 cm cube of hexane. The volume could be any volume. So they're forming two layers and there's a partition between. Now, if I try to dissolve a solute into it, and let's say I try to dissolve NaCl. Okay, instead of NaCl, I'm just going to call it a solute. It could be, let's say it's a salt. T gets NaCl, I'm calling it X. Now the NaCl can go into the mixture and it can mix with the hexane layer and it can also mix with the water layer. It can mix with both of them. But it's going to be more soluble in one of the layers. So for example, hexane is more soluble with, sorry, ये जो NaCl है, that's more soluble in the water layer. The more of it is going to dissolve in water. And a very small quantity is going to dissolve. It's going to dissolve in the hexane layer. बल्कि दो कर लेते हैं. So they're going to dissolve in a certain ratio. Okay, so if it's more soluble in water, it's going to dissolve, more of it is going to dissolve in water, and less of it is going to dissolve in hexane. Or it could be the other way around for a different solute. यहाँ तक clear है हाला? Minal, is this clear up to this point?
Yes, sir.
Yes.
So but what will also happen is that they'll form an equilibrium across the partition. That the particles will constantly move to the hexane layer, but at the same time, the hexane layer particles would constantly move into the water layer. So what you'll have is, okay, this X in water is going to be in equilibrium with the X that's present in. I mean, there's going to be an equilibrium that's going to reach between the two layers. Okay, there's going to be, after a certain time, particles constantly moving into this layer, particles constantly moving into this layer. If the rate of movement is the same, then there would be no change in the concentration of the particles in the water layer and the concentration of the particles in the hexane layer. अच्छा इसको कोई value भी दे देते हैं. Let's say there is 2 grams of X dissolved in hexane and there is 8 grams of hexane that's dissolved in the water layer. Now my equilibrium constant would be the concentration of X in hexane divided by the concentration of X in product concentration divided by reactant concentration. So how do you find concentration? It's what is concentration? Mole per dm cube, right? And so I'm going to try and find the concentration. So X in water, we'll try and find out what the concentration is mole per dm cube. So how do you find moles? It's mass divided by molar mass. So that's my moles per dm cube. So that's 50 cm cube is what? It's 0.05 dm cube. या फिर इसको simplify कर लेते हैं. It's so that one is 550 divided by 1000, right? And I'm going to write the whole thing. And I'm going to find the concentration of X in the hexane layer. So it's moles. So it's 2 grams. So divided by mR. Mass divided by molar mass. Divided by the volume in dm cube. That's 30 cm cube divided by 1000. अच्छा, तो ये clear है कि I found the concentration of X in hexane and X in water. ये clear है? Hala, Binal, is this clear?
Yes.
You get 2 grams divided by mR moles per dm cube, right? 8 gram present in 50 cm cube, so that's 8 divided by mR moles, and 50 divided by 1000, that's dm cube. But anyways, I'm going to plug these values over here. So it's 2 grams divided by mR, the hexane, ऊपर क्या है? Hexane. And then divide by what? Then it's divided by 30 divided by 1000. And the whole thing gets divided by the X in water, which is 8 grams divided by mR and 50 divided by 1000. A few things are going to get cancelled out. This 1000 will get cancelled out. The mR, because it's the same solute, the mR would be exactly the same. That will get cancelled out as well. So your expression would now be 2 gram per 30 cm cube divided by 8 grams per 50 cm cube. Achha, the only reason I did this math over here was that instead of converting grams to moles and the volume to dm cube, you can just go with gram per cm cube. Okay, there's no need to convert or divide by 1000 for cm cube dm cube conversion, because that is kind of redundant, because 1000 will get cancelled out anyways. But converting it to moles is not important, because dividing by the mR would also get cancelled out, because it's the same substance. So it's going to be the same mR. तो ये clear है? तो आपने बस क्या करना है? 8 gram per 50 cm cube and 2 grams per 30 cm cube. You're going to find the ratio. ठीक है? Hala, Minal, is this part clear?
Yes.
Yes.
और बस ये निकालो, फिर solve करो. What do you get? It's going to be 2 over 30 and times ये उल्टा हो जाएगा. 8 over 50 divided by 8 over 50, so that's going to be into 50 over 8. So it's basically 5 over 12, I guess. So what does your calculator tell you? What's 5 over 12?
0.417.
Your KPC is 0.417, and it's got no units. Remember, KPC has no units. कि ऊपर नीचे ना सब कुछ cancel out हो जाएगा. So KPC has, every time it's not going to have any units. Okay. So 0.417, that's it. That's what your KPC. I said that's what your KPC is. So that's what our KPC is, and और ये ratio पता लग गया. And this ratio doesn't change. It's the equilibrium constant across this partition. He gets the concentration of X over here and the concentration of X over here. Product concentration divided by reactant concentration. Product concentration divided by reactant concentration. And that's your partition. Okay. So KPC is going to be a constant for, so I said the importance of this is, okay, there are lots of partitions that exist naturally. I mean, the KPC clear, right? Okay, what is KPC, right?
Yes.
Or a large value of KPC means that the solute is more soluble in the numerator, and a smaller value of KPC means the solute is more soluble in whatever is in the denominator. Okay. So KPC large means solute has higher concentration in numerator and vice versa. ठीक है, ये clear है? अच्छा, इसका फायदा क्या है? फायदा ये कि remember KPC is partitions exist naturally everywhere in the world. It's always two layers and a bunch of particles that are moving across the partition. Okay, so for example, the human body has a partition. Okay, so and that partition exists almost in every cell or every organ. Okay, there's a fat layer, and then there is your aqueous layer, which is your blood. And you have various substances that are traveling, right? So now, so if particles are flowing, if they're more soluble, so and there are all sorts of different particles. If they're more soluble in the fat layer, then they'll all cross the partition and they'll move to the fat layer, right? And if particles are more soluble in the aqueous layer, if some other particles are more soluble in the aqueous layer, they will cross the partition and they'll move to the aqueous layer. ठीक है, तो आपके blood में ना this thing is constantly going on. Particles are crossing partitions and they move wherever they are more soluble. The harmful effect of this thing is that over time, what happens is that your fat is pretty stubborn. Okay, your fat is constant. It doesn't really go away. Okay, the aqueous layer or your blood, okay, that is something that gets recycled many times a day. Okay, you're constantly drinking water, so the aqueous layer constantly gets thrown out and gets recycled. So there could be harmful chemicals that you can consume. Okay, through drinks or any other way. Okay, by breathing as well. And if they are more soluble in the fat layer, those particles would start accumulating in the fat layer. And they would eventually build up. And they're going to stay in your body because they remain in the fat layer. Or vice versa, if there are particles which are normally we consume uh, particles via water, right? So they're constantly moving into the fat layer. So we don't want harmful chemicals to build up inside a fat layer. That would be a dangerous thing. We want harmful chemicals to go into the aqueous layer so that they can be thrown out of the body, right? So, okay, so partition is like something that's really important because partitions exist in chemical processes in a lot of places. So, इस पे दो ही question आते हैं. First one is they ask you to calculate KPC, which we already did. The second type of question is, so this question is that KPC is known. What you need to do is calculate concentration or calculate mass in one of the layers. Okay, so the reverse. So for example, I already know, I already calculated the KPC, which is 0.417. Okay, that's already calculated between. So I have another question, which is that there's another container, and that container has water in it. And there is 60 cm cube of water. And there is, let's say, 10 grams of X. Okay, same solute. If it has a different solute, then things are going to be different. So now I add 10 cm cube of hexane to it. Now what will happen is, okay, there's some amount of X will go into the, there's going to go into the other layer, but I have no idea what amount. Okay, so let's say I say that X grams of X, बल्कि A grams, B grams कर लेते हैं. So B grams, B भी सही नहीं लग रहा है, एक सेकंड, X ही रख लो. So I say X grams of, so I'm going to turn this into capital X, 1 second. So 10 grams of X, so a small tiny amount X grams goes into the other layer. So यहाँ पे the amount will decrease a little bit, right? So X grams decreases from the first layer. Is this part clear? Okay, I added 10 grams in the water. I then poured hexane from top. Some of the X will go into the other layer. So the mass over here will increase and the mass over there will decrease. Is this part clear? ये 10 ग्राम थे तो x उधर चला गया
Yes. Yes.
और पीछे 10 minus x रह गया. Now I'm going to find x. So KPC is what? KPC is x over 10 cm cube. You get mass over volume and mass over volume for the other one. So नीचे क्या होगा? It's going to be 10 minus x grams divided by 60. So anyways, and KPC is already know that was 0.417. वो पिछले part में we did calculate KPC, which is going to be a constant, and like any equilibrium constant, it only changes with temperature. So you got 0.417 is equal to x into 6, I think, and then 10 minus x. And then I have to solve for x. So 10 minus x, if I take it to the other side, it's going to be 0.417 into 10 minus 0.417x is equal to 6x, and that's 4.17 is equal to 6x plus, then let's go solve, so it's going to be 4.17, and you subtract, and that's 6 plus, yeah, again. So what is the answer that we're getting for x? Inal kya hai? Ala, what do we get?
0.649.
0.649 now. So यहाँ पे जो mass that goes into over here, that's 0.649 grams. And 10 minus x would be what? It's going to be कितना हो जाएगा? 9. 649 हटाना है, that's going to be क्या होगा? What's 10 minus 0.649?
$9.351.
So was पता लग गया कि what is the amount of x? So remember, I had 10 grams of x in 60 cm cube water. Now I assume that x grams travel to the other layer. तो वहाँ पे x हो गया, यहाँ पे 10 minus x हो गया. And then I use the partition coefficient expression, which is x divided by 10 and 10 minus x divided by 60, right? And KPC value I already had. I solved for x and I got 0.649 grams. ठीक है, उसका मतलब at the end of the day, 9.35 grams of the solute will be in this layer and 0.649 grams of solute will be in the other layer. ये clear है?
Yes.
बस ठीक है, ये KPC है. Just two questions on KPC. One is you find KPC and the other one is uh, that KPC is known and you have to work your way backwards. इसमें बस एक sometimes they link KPC with intermolecular forces. So what happens when KPC and intermolecular forces, which is that you have to understand that uh, a substance, मतलब solute की बात हो रही है, if it has the same, if it has similar intermolecular forces, या इसको किस तरह लिखना चाहिए, substance is more soluble if it has similar intermolecular forces. So if it has similar intermolecular forces, so अगर ammonia होता ना, I mean, you'll be asked to explain, like if you add ammonia, ammonia would be more soluble in water because it is able to form hydrogen bonds. It will not be soluble in hexane because hexane cannot form hydrogen bonds with ammonia, so it's not going to mix with hexane. ठीक है, ये बात clear है?
Yes.
वो बस पूछेगा substance उस लेयर में क्यों soluble था, तो आप बताओगे कि उनकी इंटरमॉलिक्यूलर फोर्सेस मिलती जुलती है. ठीक है, चलो ठीक है, मंडे को कंटिन्यू करेंगे. और ये वाला चैप्टर, दिस चैप्टर इज डन. ठीक है, विल सी के we're going to do more past papers now, but then I mean there's one partition coefficient that's left, lekin that one is going to be studied in another chapter. ठीक है, तो चलो ठीक है, मंडे को ना हम इसको थोड़ा और इसके पास पेपर्स ना मिक्स करके we'll do those. ठीक है, ओके मिडल. ठीक है, अल्लाह हाफिज.